Okay, guys, for tonight, we're going to talk about a basic carburettor, and we're going to try and go as basic as possible. This training's probably not for the person that's already a technician or motor mechanic. It's more for the enthusiast, so they can learn and know how a carburettor works basically. We're going to talk about the downdraft carburettor because that's what's on most of our cars. So the next thing, the thing we have to talk about first is combustion. We have to have combustion to make that engine work and to transmit the torque down the drive line to the differential, to the wheels, to make it all happen. So I want to find out from you guys, from this question about combustion, what do we need for combustion? So there is our correct answer, guys. Fuel, air and heat. Of course, the fuel from our fuel tank, our air from the outside of the car, and also the heat is the spark to make our fire. Very important that we understand this when we talk about a carburettor, because the carburettor just does not do one thing. And we must remember that the carburettor supplies the fuel and the air. And the air must be in very small droplets, and we call this atomization, in an atomized state. If we tip raw fuel in, just like from a garden hose, it will be way, way too rich. And of course, the engine won't run properly. But at different times, we do tip fuel in like that when we want a lot of power, and we've also got the RPMs behind the engine. So how do we get the fuel up to the carburettor? Of course, with a fuel pump. Now, there is mechanical fuel pumps, there is electrical fuel pumps, and also there's the old vac tank or a fuel tank above the engine, like in an A model Ford. On the intake stroke, you can see that we have our little camshaft here. We have our lever, and when we go on to the rise of the camshaft, this is not opening the valves, but on other parts of it, it will have the parts for opening the valves. It pushes the lever across, pulling down this lever and pulling the diaphragm down. When this happens, we create a low pressure or a suction, and the fuel is brought through from the fuel tank to the little valves and into the chamber. So that is the intake stroke of the fuel pump. We go to the next stroke, which is the discharge stroke. And now we've come off the base circle of the cam. The lever is going towards the cam. It's not being pushed away. It is then pushing the diaphragm up, opens the valve, and the fuel goes out to the carburettor. Of course, when we've got plenty of fuel in the float chamber, in the carburettor, we can't keep on pumping it in, because otherwise it's going to overflow, go down the venturi, and of course it's going to start running really rough. So when there's enough fuel in the float level, which is just over to the side here, and it's controlled by the needle and seat, this determines if the pump is going to freewheel or idle and not pump any more fuel. So, hopefully you've been listening. Mechanical fuel pump, our first question. What tests can be performed for a fuel pump? 2 tests, or 3 tests, or no tests? Which one would you like to pick? And of course, it is the vacuum and the pressure test. Of course, when we are drawing the fuel in, that is the vacuum test. So you can put a vacuum gauge on that side of the fuel pump and see if it is pulling a vacuum. And then on the other side, you can put a pressure test in there to see how much fuel pressure we are making. And usually these specifications are in the manual of the vehicle to test what they should be, or on Google. So remember we spoke about combustion, and we said that there needed to be fuel and air. Well, this is the air-fuel ratio chart. And at the moment, I've only got, the air is the first part, about in the middle here is about 14.7 to 1 air-fuel ratio for our car to run at operating temperature, at idle, and light throttle. When we go through the different operations of a carburetor, you will see on the right-hand side of the screen, I have put the air-fuel ratios for that situation. Rather than putting them all here, you won't remember them this way. The other way, when you see a picture and I've described how it all works, then you will. So, the Venturi. This is the main part of our carburetor. On this diagram, you can see that we have a part that comes in, and this is the smallest part across here. This is the part that will create the highest vacuum, the more drag, because how do we get the fuel? We know it goes into the float chamber, and how do we get it into this Venturi? Well, we need a high vacuum to pull it into this area. Of course, we have a low vacuum up the top and a medium vacuum down the bottom. So the first part of the carburetor is, what I'm going to talk about is the float system. Everybody uses the toilet every day. And of course, we have a float inside the actual water part of the flush for flushing the toilet. It's got the exact design, same design as the float chamber in a carburetor. So let's have a better look at the inside of the flush. So as you can see on this side here, we have a water level, we have a float, we have a on-off valve, and of course, when the toilet flushes and the water goes down, well, the float will go down, and of course, our little valve will open up and allow more water in, ready for the next time the toilet's going to be used. So just keep that in mind now when we go to the carburetor. Here is our float. Here is our needle and seat. And of course, this is where our fuel is coming from, our fuel pump, and goes into this area. Of course, when we use the fuel out of here, the float will go down, and of course, the fuel from the fuel pump will come through and fill it up, goes to the top, closes off the needle and seat, and then we have a scenario where the fuel pump will be at idle. Problems that we can have with this float chamber. If this float here gets a hole inside and fills up with fuel, the float chamber float will go down to the bottom, stay there, the needle and seat will stay open, and of course we'll have fuel just keep on pouring in, and it'll get over the top here and just pour down here. Or if it's got a vent system on it, it will pour out the vent. So this can be caused by a float that could have a hole, or the needle and seat that is worn, or something jammed in front or in the needle itself, not allowing it to shut closed. Now, on most old cars, my recommendation is that prior to the carburetor, you would have a fuel filter, an inline fuel filter. because we know old cars that have been lying around, what happens to the fuel line? It's made of steel and it has rust, and those little bits of rust will come through and keep that needle in the seat. So it's probably best to replace the fuel line with a nice copper one to stop that situation happening. So we're going on to the idle circuit. So you can see up the top here, I've got a big blue arrow. So this is our air, 14.7 to 1 part fuel. And of course, my yellow arrows showing the 1 part. The actual fuel float chamber is full. The engine is running, and we need to take fuel out of here, which it goes up this metering orifice here. It goes to the idle tube. You can see at the top of the idle tube that we have an air bleed, and air is coming through here because at this stage the butterfly is virtually closed, just a fraction open to uncover our idle port. So the fuel that's coming down here is a mixture of air and fuel. If it was complete fuel, way too rich. Too much air, engine too lean. So we slightly move our foot off the throttle, and it's light throttle, and I have put the air-fuel ratio here about 14.3, but it could be still around the 14.7 to 1. You can see the butterfly has opened up a little bit more. We've got another 2 ports uncovered, and of course we've got fuel coming out of the float chamber, coming up our metering port, bringing in air with it, breaking it up and atomizing it, and we've just taken off. We haven't put our foot to the floor or anything, we've just taken off, and if these ports are blocked, what will happen is you'll have a flat spot from idle to the next stage of the carburetor. Main jet operation. So again, we've opened up the butterfly a lot more. We've gone past the actual progression ports and the idle port. We are now dragging the fuel, and we know, as I told you before, that the vacuum is at its highest point in this part of the venturi. This will cause the fuel to be drawn out from the float chamber through the main jet, and it has to go through a system here where we have to break up the fuel and mix it with air. You can see the high-speed bleeder where air is dragged in, and the component that is put inside there to break up the fuel and air is the emulsion tube. And the emulsion tube breaks up the fuel, and now we have our air and fuel ratio. So, question time. Main jet operation. What component in the carburetor aerates the fuel in the main jet operation? You've got 3 to pick from. So does the emulsion.
I was going to ask Bruce, is this a time to pause and let anybody ask a question?
Yes,
I've got one there now on the chat from Lee. How does the emulsion tube aerate the fuel?
Right, I'll go back. Okay, so Lee, on this one here, you can see that we've got the high-speed bleeder. So the high-speed bleeder pulls air in and causes like a turbulent in there, and the emulsion tube is designed to break up and mix the fuel with the air. That's how it's done. So if this tube gets carbon in it and what have you, and starts blocking up, well, you could have a lean fuel situation or a high fuel ratio, a rich mixture. Does that answer your question, Lee?
Yeah, thanks, mate. I was just sort of wondering how it actually managed to do it. If there was like perforations or marks on the outer of the tube, even just to cause that turbulence realistically.
Yeah, well, it has got little holes in it and what have you. Worthwhile when we actually probably do this as a Technot in a practical sense, that we actually have a carburetor and we take this part out of it so you can see it. But this is one of the parts when you overhaul a carburetor, you must clean thoroughly so you have that correct air-fuel ratio. Okay, any other questions? Okay, we'll continue on. There's our answer. Okay, so the next one we've got is the power valve operation. Why do we need this in the carburetor? So guys, we're driving along the road and we have got a headwind. The car starts to slow down if this is not working correctly. This device here is to give us more fuel when we have an increase in vacuum. Or the other situation where this would work is when we start climbing a hill. It causes more fuel in the main jet system. So how does it do it? We have a vacuum line connection, which comes from the bottom here, comes up across, and we have a little plunger. When we have high vacuum, this plunger is pulled up and there is a little port that it uncovers and more fuel can be dragged through this port, also at the same time through our main jet, and of course it gives us more fuel. So about 12.7 to 1, roughly, those figures are, because there's a lot of variance on what type of fuel you're using and so forth for those air fuel ratios. So that is our vacuum valve. And of course, if you've got a vehicle and you've got a lot of weight in it and you're driving it around, this power valve will be working all the time, and of course you'll have high fuel consumption because of it. Okay, another question for you. What operates the power valve? Oh, 100%, how's that?
Yep.
Everybody knows what a power valve is now. Everybody will be going out to their cars when they get high fuel consumption saying, oh, that power valve must be on, or I got too much junk in the car.
I've always
very
wondered
good.
whether I had one. It doesn't feel like it sometimes.
Yeah, just depends how much power your engine's got and how big the carburetor is. Okay, so intake manifold, vacuum. Okay, so we'll continue on. We now go to the accelerator pump. And this is a component when we put our foot flat to the floor because we reckon our power valve isn't working correctly. So it's like a plunger, and you can see the toilet there, and it's like putting the plunger in the toilet and pushing it hard through and moving what is stuck in the toilet. And then of course it's going to come out like a fire hose in the main venturi, not with any air with it, just straight fuel. So our accelerator pump operation, you can see here is our plunger. Of course, this is in our float chamber looking at it at a different direction. The float's over here. The main jet's in behind there. And This fuel does not come out the same spot as the fuel comes into the Venturi from the main jet. This is a separate tube that comes up and squirts in just like the fire hose. No air in it, only fuel. Of course, guys, this is operated directly off a mechanical linkage off the throttle valve. On some vehicles, there is 3 different spots, and all that does is give you 3 different settings, how you want to set up your accelerator pump. And of course, in this situation, we've got 12.2 to 1 air-fuel ratio. Another question for you. What operates the accelerator pump? So just remember, it's the mechanical linkage off the throttle shaft. The one that's hooked up to your accelerator pedal inside the car. Okay, so we now go to the choke operation. So in our older cars, we didn't have automatic chokes. We had the knob on the dash that would pull out. And of course, what that does, guys, is it puts this choke valve across the top of the Venturi. So any air that has to go through the motor or into the motor has to come through here. You will see this little valve, so it will let a little bit through there, but it creates a big vacuum, and it's going to drag fuel from every spot it can get fuel from. You'll notice that in choke operation, our butterfly is opened up a little bit further, so we've got a higher rev, because otherwise we'd smother it with too much fuel. So you can see it's coming through the main jet, it's coming through the idle, the progression ports, and everything. When we're actually turning over the engine, we have an air-fuel ratio of 2 to 1. This is seriously a lot of fuel that is going into the combustion chamber. And once it fires, it then goes to 6.1, and then of course we're straight on to the choke cable, opening it up a little bit because we're suffocating the engine and we've got all this blue smoke or black smoke pouring out the back of the vehicle with it being far too rich. And we just adjust it to that nice medium. So what I've done here is I've got some pictures of some early Valiant carburetors, because there was a member that wanted to know a little bit on setting the choke system up on the vehicle. So you can see on the carburetor that's right in front of us, we can see the choke flap leakage on the side. And of course, you'll see this component that bolts onto the exhaust manifold, which has a bimetallic spring inside. And the idea of that is once the engine starts heating up the manifold, and of course, it will cause this rod to extend and to pull the choke flap back to being fully open when it is actually warmed up. Remember that we need to have fast idle. So you can see on the side here, we've got 2 screws on an automatic choke system. So we have our normal idle speed of 1 screw and our other screw, which is our fast idle screw. To set this carburetor up properly, you usually find in the manual it will have a fast idle choke setting. So what you need to do is you need to push the accelerator down and get the linkage to fall over, and to see how many revs it says that the engine should be running at with that fast idle operated with the choke. So you can only do this for a couple of minutes. You have to be quick. Have your tacho on the side of it, and you can see what specification it should have. On the side of the choke, this bimetallic spring inside here only has a certain lifetime. And when the vehicle starts having problems of not allowing the choke off fast enough, you really need to replace this. But what a lot of people will do is they'll start bending this linkage here to try and get it to work as it did when it was new. But better just to replace it and put a new one there. So they're the two adjustments on the choke system, the fast idle and also the choke flap adjustment. So question time. What adjustments are on the choke system? One of those is correct, guys.
Hey, Bruce.
Yeah.
I was meant to say, you said those choke thermostats mount on the exhaust manifold. They actually mount on the intake manifold.
No, definitely on the exhaust manifold on a 6-cylinder.
Well, you were
So
showing
maybe on a
that.
V8, it could be there.
Yeah, I
because
thought they look like V8 ones to me, but I've never, they're definitely
they're on a
the intake
6-cylinder
manifold.
there normally, because the idea is to get the heat off the exhaust manifold to start taking or start opening up that flap.
No, it normally sits in the crossover in the centre of the intake, and that's where the heat comes from on a V8. But yeah, I mean, you were showing V8 ones there. That's all I was just saying anyway.
They're exactly the same as the 6-cylinder ones.
Well, I've never seen one on the exhaust, but maybe on a 6-cylinder. But I've done a million of them, and they're always on the intake. But anyway, I'll leave it to it.
On a V8 probably, yes, because it's too hard to put it. But on a Slant 6 S-Series Valiant and AP5, I believe that they're both on the exhaust manifold.
Fair enough.
Yeah, we've just
Cool.
learned something. Both
Hello?
of us.
Hello?
Hello?
That bimetal spring, when you
Yes.
install it, is it
Yep.
wound up or unwound?
It's wound up and you buy it with the whole housing.
Yeah.
The other one,
I've
what
got a
you're
new-
talking about,
Yeah, I've got a new one and I want to install it, but I didn't know whether it was up tight, like a clock wound up, or loose. So when it
so
gets
how
heat,
big is the spring? Is it an inch across, the spring?
it looks
Or is
very
it a
much
lot-
like the one that you were showing us, but maybe 20 mil diameter. Yeah. When it's
Oh,
open.
yeah.
When it's open.
Yeah, you would put it in there with a little bit of tension. Because
Right.
we've also got the heat box one that we
Yeah.
also have a biometallic spring on it also, on a 6-cylinder.
Your mine's on the 318 V8, which is.
All
on the
right,
manifold.
okay.
Yep.
Yeah.
Okay. I've had
Yeah,
to
that's
You
just
can
sort
buy
some-
them brand new, all complete,
Where?
on eBay. I've seen them there.
Oh, okay. Yeah, I bought one at Mopars on the Murray from a guy from Queensland, and he jibbed me. He sold me the wrong one, and
All
he's got
right.
me $40 and blah blah blah. But
Okay, another
yeah.
place that you can try is on the internet,
Yep.
a place called Rock Auto, and all those
yeah.
parts are very, very cheap.
Oh, good. Brock Auto.
I bought a exhaust manifold for my S-Series Valiant, and I think it was about $350. Then I had to get it here.
Oh, okay. Yeah, but all I'm wanting is that brand new choke system. The
Yeah, get the
what you
whole
bolt
thing.
on.
Yeah,
Yep.
rather
yep.
than mucking around trying to fit it. But anyway, if you do fit it, it needs to have the tension on it so it closes the butterfly completely. Virtually
Yeah, so
completely.
it's got to pull down then, doesn't it?
Yeah.
Okay. Yeah, I just rigged up something else.
Yeah.
I've just got a screw standing up off the manifold, and using that lever that does that job, I've just got it tied down with a clip for a moment while it holds the choke shut. Once the engine's been running for a few minutes, I just take a dog clip off, and it releases it, and I'm on my way. It's just a little bit of a fiddle, but it's just on the new Duster to get it so that it needs a choke to fire it, and you can't do both things at once.
Definitely.
You know what I'm saying? Okay. Oh, thanks
Yep.
for that. Thanks
Yep,
for that.
no
Got to be
worries.
wound up. Thank you. Bye.
So guys, all these setups for the carburetor and the choke system, we really need to look at the basic tune of the engine before we start doing anything. So what I mean by that is, if we know the engine's got good compression, that's fine. If it hasn't, do a compression check and find out if we've got leaky valves or leaky rings, whatever. We then need to put the right spark plugs in, the right heat range, and also the right gap. And then, of course, we go to the distributor, check the points out, make sure we've got the right point gap. And I'm a believer in checking the point gap with a dwell meter. So a large dwell, small gap, large gap. I've probably got it around the wrong way now. Anyway, so we need to do the dwell angle on the car and set it up to specifications. Then we need to put a tacho onto the vehicle and check the idle speed, and then we need to check the timing of the engine at the correct idle speed, because if we've got the idle speed too high, we're not going to have the right timing for the engine. The engine should be able to sit there and idle and should not start overheating. If it starts overheating and we've got a good cooling system, we've got a good idea that the tune of the engine is out. So, and of course, we need to adjust the mixture, so it is at the smoothest running part of the engine. So they're the basic adjustments on the engine before we start playing around with chokes and what have you. Because if you don't have the basic adjustments right, it ain't going to run right when it's cold on the choke. Of course, on the carburetor that I saw this on eBay. You can still buy plenty of the kits and everything. The accelerator pump, the needle and seat, and all the gaskets for the carburetor. So this is for a slant 6 engine. I've also put here a little table here of, in basic terms, what the air-fuel ratio, not with figures, but just with words. So hard acceleration, extra rich, just to give people an idea of what is happening at cold start, what is happening on deacceleration, and so forth. Then I've shown a air-fuel ratio with gasoline. The air-fuel ratios, part throttle, as we said, 14.7. What it would be with an alcohol engine, what it would be with a diesel engine. And of course, we've got another thing here where we've got lambda. Now, lambda is when we have a O2 sensor, we have a catalytic converter, and of course, when the car is sitting there idling, to make the catalytic converter work correctly, we need to go mixture, rich, lean, and this is the lambda, which oscillates back and forwards. And you see this on a meter. So, question time. Is there any questions?
Yeah, I just wanted to say again, Bruce, I think we got our wires crossed before. You there?
Yeah, I'm here.
Yeah. What those choke thermostats you're showing, they are V8 ones that sit on the intake, and what you're talking about on the exhaust manifolds, V8s have them as well as 6 cylinders. That's your heat riser valve, and the heat riser valve has another bimetal strip in it, and that shuts off the flap, so that the hot air stays up the top of the engine and into there, so that the
intake manifold. Yeah.
So that it heats that up quickly. So that's a separate thing actually. Again, and on a 6-cylinder. For the choke flap, you obviously have a choke, you know, a cable on the dash.
On a 6-cylinder, no, they do have automatic chokes, and they do have that bimetallic strip thing like the V8, exactly the same. Next time I see you, I'll take a photo of the one on my car and show you.
You know, they do have it. What I mean is the actual choke thermostat. It's not the heat riser, like the flap inside the exhaust manifold. That's
no. They still have, yeah, they have that. and they also have the choke flap that is on the carburettor.
Okay, I should better start working on some 6-cylinders because
Yeah,
working on
yeah,
thinking V8.
you're only V8 orientated, which isn't a bad thing.
Well, I've just bought a Barracuda with a 6-cylinder, so I'm going to learn quick. But
Yeah,
the
it'll
last
be interesting to see. The early ones had that component. Some of the carburetors have different devices on them. Some have a hot water device. Some have a electrical bimetallic, which when you turn the ignition on, as soon as you've started that car, the current from the ignition system goes to it and starts heating it up, and then it releases the choke flap. So there's all different types of them.
Well, most people go to that in the end because it's just the simplest, easiest one you can buy new, isn't it?
Yeah, that's right.
Basically, my old
let's-
Hemi's got a stupid pipe that comes up from the back of the exhaust manifold and goes to the side of the carby, and everything blocks off. Everything blocks up, and then it breaks the Bakelite bit out of the carby, and the whole thing's just a schmozzle.
Yeah.
So
The best thing is to make your car fuel injected, and then you get away from all those problems.
you're talking to a bloke who'll never have anything but points, so we better agree to disagree there.
Yeah, that's right. The modern car, they've certainly got it really good now of starting and what have you with the fuel injection system.
Sure do. They sure do.
Yeah. But it's
Anyway,
taken
that's
years
better.
to get there, and we had to go through all this to get there.
Exactly.
Any other questions?
Bruce, can you run through your idea of setting the air fuel ratio like the idle mixture?
What I do there, Frank, is I always put a vacuum gauge on the engine because my hearing isn't 100%. And I watch the needle to get the highest vacuum, which usually is where the engine's running the smoothest. And of course, I look at the specification and use a tacho to look at the maker's specification of what it should be. Is there any more that you want to that, or is that sufficient?
So that's similar to what you do for balancing a couple of carbies. You just use a single vacuum gauge to get the highest back reading.
Yes. When you actually do twin carburetors, you can buy a balancer which goes on either carburetor, or if you've got triples, you need 3 of them. And you put it there and you measure the air that's coming into each carburetor and see if it's the same.
That's
Do the mixtures, you block off the idle jet and you see the idle speed on the opposite carburetor and vice versa to double check it. Do you want to do that, Frank?
Okay. Yep. No, that's fine.
Yep. So just another thing that I could have mentioned in the presentation is about everybody tunes their car up and what have you and does that, and then afterwards they put their air cleaner back on and you have a center screw, a butterfly screw, and usually everybody puts that on and they tighten it up nice and tight so the air cleaner won't fall off. You're not supposed to tighten it up when the engine is hot, because what it will do is it will warp the carburetor. So something worthwhile to know. You can re-straighten a carburetor, but it takes a lot of work. You need to have some straight edges, you need some clamps, and you need a blowtorch. And what you have to do is heat up the housing of the carburetor and then just turn the little G-clamp 1/4 of a turn, let it cool down, heat it up again, and so on and so on until you get it straight again.